Hello everyone. This video is about how to make your own Ollama client. We're going to do it from scratch rather than using a framework. Nothing against frameworks, but it's good to know how to implement it yourself. So yeah, I really like Rig and Ollama OS is good as well. So let's actually start a new project and we'll call it Ollama underscore client. Not very original, but there we go. Change into that. And let's edit our cargo.toml file. And what we're going to be using is, got a notepad text here. Request. I always remember to add JSON. I almost do it automatically. Stream. Saturday JSON. Tokyo. In fact, I might change that. I always just add macros in RT multi-thread. I think I might need one more for this. And futures util, because we want to use futures, not just Tokyo. So let's do all that. Should have copied that. Okay, so in fact, I think I'll stick with Tokyo 4 just for this. Let's not make life too difficult for ourselves. So right, I've got something in my Vim set up that checks cargo.toml. Not the fastest laptop in the world, but there we go. You'll see when we've written this code, we'll see how quick it is or not. We're just going to write a client that actually takes the response and streams it back to the end user. So to do that, let's start with the imports. Let's make this full screen as well. Right, so we want to use request because we're going to make effectively make an API request to the large language model which is running in Ollama. So hopefully you're familiar with using Ollama. If not, then plenty of other videos and articles about that. So use request. We're going to be using client and an asynchronous client. So because it's asynchronous, you'll need to use await when you use it by default. We'll also use, I almost always just do serialize and deserialize, but I think we can just use this. We can just use deserialize here. To serialize, we'll use the JSON macro, which we get from request. So that's why oftentimes you'll use serialize, but if you're using request, you won't need to use serialize because you need JSON. Right, use futures util. And we want to use the stream extension, an extension trait for streams that provides a variety of convenient combinator functions. So actually, this is more of a video about using request really, and passing a stream of bytes. So if you're not really into AI for whatever reason, this is really a fairly standard coding tutorial. Or I say fairly standard. It's hopefully beyond kind of your day one. Rust 101. So let's create a struct. We're going to need to create a struct, which is the structure of our response that we get back from Ollama, because Ollama will be returning, effectively, it'll be returning a data structure that we need to recognize. So struct Ollama response. We'll need to do some derived stuff in a second, but just to get the structure. So if you're familiar with the Ollama API, you get message, and that's going to be a message struct, which we need to write in a second. And then done, which is a Boolean, which is basically saying whether the stream is finished or not. So we've got the error there on message. So let's create struct message content. And again, this is, I've written down some notes. So this is stuff that you will need, that you would research according to whichever LLM and framework you're using. So although we're not using a framework for the client, we're still using Ollama to run our LLM. Right, we need to add some derives to this. So derive debug and deserialize. So I need to do it down here as well. Once I do that, see that error message went, because when I was using deserialize on this, it was requiring it also for message, which is part of the capital M message. So this Ollama response, it represents each chunk from the Ollama streaming API. The bool indicates the end of the stream, and the content is the actual text from the AI model. Right, so oftentimes actually getting the structs right is, I wouldn't say make or break, but it's quite critical to the success of your code. We had this because it's using async, or using Tokyo, because we want to await because it's asynchronous, because we don't know how long the response will take to arrive back, and we want it to be non-blocking. Just just for my own reference, I'm adding a timer in here, so I'm going to add in start timer, and we'll just say let's let's start equal instant now. Yeah. Okay. So let's just print. This will do some weird epoch timing thing, but we just want it to know that when it started. So we need to put that in there, don't we? There we go. Right, so we'll use a client. We'll create a client, which will be our instance of Quest client. So client with a capital C and then new. Okay, so we've got a client which we can use to make our request. The request will be sending a prompt to the LLM. We'll call it. So we need to create the body that will actually send across to the LLM. So now we need to use setDateJSON with the JSON macro to serialize all of this. Let's put in some details. What I'm going to put in is kind of the bare minimum, but you can also add in. So what do I mean by that? I'm going to pass in the model, which I'm going to use Llama 3.2. We're going to pass in the messages. So this is syntax which is specific to your large language model. But a quick look on Hugging Face or Google or ChatGPT, and you'll soon get the format that is required for your LLM so that you can talk to it. Or RTFM, look at the documentation. So we're going to add model. And then in quotes, that's Llama 3.2. So the messages, not to be confused with message, which we put into our Ollama response. That's our name, but messages is what you need to pass into Ollama. And here we say role, user, and then content. That word content is going to be, we're going to hard code the question. Just, we don't want to make this too complicated because the whole point of this is kind of understanding how we talk to the Ollama API and also how we pass the stream. So my favorite question is, why are bananas yellow? Question mark. Okay, so far so good. So I'm looking at my notes, full confession. I'm looking at my notes, but I'm not copying and pasting this in, and I'm not using ChatGPT. So I think typing stuff in is really important rather than copy and pasting. Right. So we want to, we've created our client, we've created the message to send to the client, and now we actually just need to create a response object that will be what we use to extract the stream from, the stream being the answer. So all of this down, I'll tell you in a second when we get to kind of the end of the request, and it will go from what we're sending, and then it will kind of, we'll flip over to what we're receiving. So this is still what we're kind of sending. So client, which is what we created up above. Then we're going to do post. Use the post method to send to. And if you've got Ollama running with Llama 3.2, which hopefully you have, or you know how to, so other videos will cover all that. Localhost, and then it's 11434. Unless you've changed the default port, but that if you have. And then we need the API chat. So it's other places you'll see things like API/completion and other stuff, but here we're just using /chat. Now we're going to send the JSON of the body. We use a reference to it because it's better. And send. Because so far it's not like requests in Python just where you say post. You prepare what you're going to post, and then it's like you write your letter, put it in the envelope, and you still got to actually put it in the letterbox. Then we'll wait, and then the all-important question mark. That's not looking good. think I just need the oh, because we started right. Right, let's keep going with that. I think I know what the issue is here. If not, if this response dot status, so if it's not successful, we'll just put the response status. Then we need to return return OK. What have we got here? Sing. Oh yes, I need the end quote there. Okay. Mismatch types, expect unit type, and enum result. I think it's just because I haven't got an OK at the end, isn't it? Async. If I need to return the result, that would help. Result, and then we'll just handle any. Well, we need something to bubble up to. That was the problem. What do you? I I've had varying opinions on whether to actually return a result from main. I think it's quite subjective. We just need to do box standard. Dome inbox stood error lowercase capital E error. Okay, we're getting somewhere now. Good, right, okay. And then we just need to sort out we need to put the quote in the right place and get rid of that one. And put that question mark back. That was what was causing the problem because it wasn't able to bubble it back up. Right. And what's going on here? That probably doesn't implement display. Use parentheses to call methods. I just need the parentheses on the end there. Good, right, okay, we're off to the races then. And that's going to send something. It's actually going to be sending it, but we're not really handling the response, so probably shouldn't have done that. Let's get back in. So we've created two structs. One is the message, the other one is the response struct, which needs to be used still. Created a client, we've sent the body, or we've got ready to send the body, and we've created something called res, which will be the response, and then we need to start getting ready to actually handle that. So we need to start thinking about the stream. So we need to create an object which will be mutable, because it's going to be constantly changing with each response. And then we need to say res, and this is provided by the request crate. So we need to use bytes underscore string. We also need to create something called so now we're dealing with what we get back, and we need to create something else called let mutable underscore response, and that's just going to be a string new. Okay, and so the full response, that's what we're actually going to print back to terminal. So now we're actually ready to do the fiddly bit, and I am looking at my notes here, and while let sum, we're just going to make up something called item, which will be equal to the stream dot next. So we'll keep iterating over the stream. We need to await each time, and then we need to, so the stream, each one of these items will effectively be a chunk, but it will be as a result, so we need to get the content from it. So let chunk equal item question mark, and we've got the bytes. You see, without that, the item was a result, so that's why we need the question mark. Right, next, so we're going to say for line in lines effectively. So for line, except for we need to get the text from the chunk of the chunk, which is in the chunk is bytes. So we say line in stir from line in stir from TF8. I don't know why autocomplete's not. Let's carry on anyway. And the chunk, we'll just put a reference to the chunk. And then that's a result. And then we want the lines out of, so the lines will actually be the text. And why is that not? Cannot find stir from UTF-8. Stirred. stir. I'll have to check my website on that. Let's go back to stir from UTF-8. My notes have failed me. I apologize. Stirred, double colon, stir, double colon from UTF-8. Right, happy days. Right, no, we've done that. So what we did there was we said we want to get the lines from the line from, sorry, for line in lines, but the lines weren't text, so they were bytes, so we had to convert them to text so that we could get each line out. And then now we say, because this is worth paying attention to, the line. You could have an empty line in the middle of your response. So this is where we say if line, we trim it, and then so if it's empty, we don't want to break or quit or anything, so we just do continue. That's important, otherwise it would kind of it could just exit the for loop even before it's got all of the text out of it. So yeah, really important in case of empty line in response. Let's just say mid response. Right. MIDI response? Mid response. No, we've got to get the so from that line we need to effectively convert it to JSON, match it to our struct, and then once we've got it in the shape of our struct, then we just need to get out the message content. It sounds complicated, but it's quite neat. So we'll call this past equals said a JSON from stir. Yeah. And then line, question mark. Right. Is that not happy? Did we not add this they deserialized too? I probably shouldn't have done that there. Let me just do that in let's just do cargo build. If I do it within Vim, I don't see this detail, and then this don't actually know whether it's running or not. So deserialize is not implemented for. Serde JSON from stir line. Oh, let's just cheat and look at my notes. Debug, deserialize, deserialize. Set a JSON from stir. Oh, I think it can't infer the return type, so we need to tell it. Kind of get used to Rust being really helpful, and let me just turn off type hints, and we'll put this in here. Yeah, now it's happy. It does. This is what catches me out about Rust. Is sometimes it helps you, and sometimes you're on your own. But it's not criticism. It's better than always being on your own. Right, println. Now our response is in the shape of our struct. We can hopefully do something nice with it, such as print the past message content. So past dot message. See how it's offering us the. That's nice. So it's because we'd made our struct. And yeah, then so full response. And then we want to just push stir. And then we want to pass what we've just printed to the shown on the screen, which was we just borrow that past dot message dot content. It sounds sort of hard work or long-winded, but it's not, because if you've got Rust Analyzer, it just keeps offering you exactly what you need. So then if passed, and then this is dot done, and the dot done is go, it's a ball. So it's what we already added to our struct. The reason we added it to our struct is because that's what the Ollama documentation, or once you read about Ollama, you know that it sends back done at the end of the response once it's stopped streaming. And now we're just doing some, just printing some stuff to the screen, really. So this is the easy bit. So we just say let duration. So we'll just see how long it took. Equals start. It's dot elapsed, isn't it? Elapsed, yeah. Println. We just do done. Fine. I mean, you could do whatever you want here, really, but this is where we'll just print the full response. So you will need to do that in some shape or form. That's the whole point of whole point of this code. And then we just do full response inside that. And then we'll do, I will print the elapsed time. This is quite near and dear to me because my laptop is very slow. Elapsed time. That's called duration, and then we just need to format it 2 decimal places. Question mark. Oh, sorry. Need sorry about that. Then we need the colon there. That's more like it. Close that. Happy? Yeah, good. Right. And then we just need to return OK. Return. OK. And we've already done our OK at the end. So this should, famous last words, this should compile. And it should ask the LLM why banana's yellow. just got, that's, don't ask me what the TV_sec is. It's just kind of like some random number, which is a sort of a reference point. Hello there, I'm not actually a llama, but I'll play along. Um, this wasn't what I was expecting, but it's kind of working. We'll see what. I'll show you my first attempt. By the way, I'm an AI assistant, not a banana expert. There we go, 52 seconds. And so the push to string actually builds the more readable full response. So that's why we did the full response. 52 seconds. This is a i5 running at 1.6 gigahertz. So don't let that put you off. Don't let that put you off if you've got a more modern computer that could do this in kind of probably a quarter of the time, something like that. So the full response, that's what gives us the nice response. Without that, we would have that weird streaming. I think I've missed something out here, but I've been working from my notes and everything's worked okay, really. But apart from when's it? I'll have to think about that. Why it did the streaming like that. If I show you I'll show you my article, my website, and if this takes about 4 seconds, so there we go. And yeah, do you see that? How it's presenting it per line. I'll need to go back to the drawing board on that, but hopefully this has given you some nice reassurance that you can actually make your own. You don't have to use a framework. So all we really did was we used our knowledge, or we researched how the response is formatted from Llama 3.2 with Ollama. And all this information is available either through Hugging Face, Google search, or Ask ChatGPT, Claude, etc. So you make, as ever, even if you're doing something like ActixX or whatever, you'd make a struct for your response. You have, and that message is just part of the response. We're doing a post, which is sending the body, and the body is constructed of a model and messages. Now you can take that further, and you can also include top P, top K, seed. Seed is like when you use rand and then you specify a seed like the number 42. It just ensures that you're developing against something which is deterministic, which as a developer is probably what you will want, but I'll just turn off type hints again. So Rust is free, Ollama's free. All this is costing you is your elapsed time. So thanks for watching. Any questions, put in the comments. This really is an intro to using an LLM without any framework, and it's deliberately without any framework. So I know there's Ollama-RS, I know there's Rigger.rs, but this is really just, if you can build this, then you've kind of got a good grounding in how they work. And just, I think these days it's called is it a mental model? Yeah. Anyway, thanks for watching. Thumbs up, like, subscribe, and all that. Thank you for watching. Bye.